Hello and welcome. In this video we are going to expand your repertoire with Python a bit by introducing how to deal with exceptions. So we'll look at how we can make our scripts handle errors that might occur while our script is running. In the past, if something went wrong, if something unpredictable occurred to your script, it simply had to crash. And you get this generic error message from Python indicating what file it was, what line it's on, and some information about what went wrong. And ideally, you debug your script and wrote it better. But, you can't always predict every possible thing that might go wrong, or things might go wrong that you didn't predict, and you give your code to somebody else, and when they run it, it crashes, and then it just looks bad on you. With what we look at today, you'll be able to have your scripts deal with these kinds of issues somewhat more gracefully. Instead of just crashing with that generic error message, you can control what happens. You can give an error message, a customized error message. You can have the script exit under control instead of just crashing. Depending on what exactly went wrong, your script might even be able to continue in a slightly different manner. So this will all make your scripts somewhat more robust. Now this does assume some basic knowledge of Python already, and not much. I'm trying to keep this as simple as possible. So just things like creating and using a variable, running a script, being able to print out output, and the way Python needs to be indented in order to function, but nothing beyond that. I'm deliberately keeping this as simple as possible so that we can focus on what an exception is and how to handle one, as opposed to worrying about some complex code that might actually cause a real exception. Of course, what we look at here, you can then apply to that more complex code. But the piece of code that's going to start this all off for us is the try statement. When we have a chunk of code that we think is going to potentially cause a problem, for example, we're trying to open a file that the user gave us the path to, but users being unpredictable, we can't be certain that that file exists, and if we try to open a file that doesn't exist, of course we're going to get an error. We can use a try block. It's simply the word try, colon, and then an indented block of code that might cause some problem. So to demonstrate this, we'll head over to my demo machine. Per usual, I have a number of scripts pre-written here. Before we start running any of them, I will mention I've given myself I've given an admin execute permission to all of them. Python 3 is installed on this machine, and it's the only version of Python on this machine because it's a recent release of the operating system. And I know there was a third thing I meant to mention. Oh, that the current directory is in my path, so I can just call these scripts by name. So if I try to run the script try.py, it's going to crash. And I'm sure you've seen error messages somewhat like this. This file, well, I should highlight this, the file that you were trying to run, this line, here's the line of code, and it ran into this thing called a name error. This name, var, is not defined. Well, what actually happened here? Let's open this up in VI. It's a very, very simple script. I'm using a shebang line appropriate to this machine. I've got a block comment, which I thought I caught all the typos in these beforehand, but apparently not. Simple Python script to demonstrate a Python exception. And it's trying to print out some output, but I'm making a very simple mistake. I'm trying to use a variable that doesn't exist yet, so it crashes. Now, realistically, the solution to this would be actually instantiate your variable before you use it. And then your script runs normally, but again, I'm trying to keep this as simple as possible. I'm choosing an exception to cause that is this simple so that we can concentrate on learning about exceptions and not on trying to figure out some reasonably complicated code. So I'm going to take that back out, and as we saw, the script crashes. So the way we handle this is by introducing that try statement. Before I run this, let's look inside it. I'm going to mention this script as well doesn't actually run. But what I've done is take that line of code that tries to print out that variable that doesn't exist yet, and I've put it inside a try statement. So the word try, colon, and indent from then on, and this is the block of code where I expect something might go wrong. But when I do try to run this, it still doesn't work. It actually hits an end of file while it's trying to look at that try block, because try on its own isn't enough. There's a second keyword it needs. Except, try says, I think something might go wrong here. Except says, and here's how I'm going to handle it. So after your block of code of here's what might go wrong, you use the keyword except, colon, indent code from then on, and put in some code of what you want to happen if something goes wrong. So this time, my script doesn't crash. It gives me a customized error message, something that I want my script to say. Let's actually look inside our script and see that. Again, it's still pretty straightforward. It's mostly a block comment up here. But we are trying to print out this variable that doesn't exist. And if we run into something not working, like, say, the variable not existing, we get to decide what happens. Our script can continue under control instead of just crashing. So, yeah, I can give this message because I've debugged my code and said, yeah, that variable isn't defined. I can't print it. Of course, there are many, many other things that could go wrong beyond just this try value, or beyond this name error, that is. So the except statement on its own, it works, but it will react to any possible exception that occurs. There will be times when you only want to handle certain exceptions, because there are some exceptions you can recover from. Oh, this variable doesn't exist? Well, I'll put a value in it and I'll try again. That file doesn't exist? I'll create the file and then open it. I don't have permissions to open that file? Okay, maybe that's something I can't do. Or maybe I try to change the permissions on the file so I can open it, and if that fails, then my code has to admit defeat and exit. So to handle specific exceptions, in our except block, after that keyword except, we include the name of a specific exception. If this thing goes wrong, here is the code to run, which I was trying to highlight there, but it didn't work. So I have put that in try2.1.py. If I run into that name error, all right, variable's not defined. I can't print it. And if I run that, yeah, that works. But if I create a different kind of error, this script still crashes because I'm not handling that error. In this case, it's a type error. You can't combine a string and an integer that way. Because when I created var there, if you quickly caught that when I did that, I made it an integer. And here where I'm trying to print it, I'm just trying to concatenate it as a string. But I'm only handling that name error exception. So I'll undo that because I don't necessarily want that sticking around in my example. And if I look at try 2.2, I do that same thing, but I can actually handle several different exceptions. Let's go back to my slides. If you want your except block to be able to potentially handle multiple different exceptions, but not every possible exception, just give a comma-separated list surrounded by parentheses. So, except, space, parentheses, the name of an exception, comma, the name of another exception, comma, the name of another exception, for however many exceptions you want, close your parentheses, colon, and your indented block of code. If you write your code this way, any of those exceptions will get handled the same way. That, however it is you want to handle it, give an error message, create the variable and try again, try to create the file and then access it, whatever. All of these exceptions we deal with it the same way. And we can kind of see that here where, yeah, if I run into a name error or a type error, I will do the same thing. So as we saw from my 2.1 a minute ago, if I run this, it would actually cause that type error because I have var as an integer, not a string, but I'm getting the error message, it's not defined, I can't print it. If I go back in and I make this cause the name error again by commenting out that code, we still get it's not defined, I can't print it. So certainly there will be times where you would want to handle multiple exceptions in the exact same way, but there will also be times where you might respond differently to different exceptions. All we do for that is just have multiple except statements. And again, I was trying to highlight actual text, not just that block. So I could say except some exception and have my indented block of code. Here's what to do if that exception occurs. Once I've dealt with that, except some other exception. And here's what to do if that error occurs. So we can see this in my try3.py. If I run into a name error, okay, the variable is not defined. I can't print it. Instead, if I run into a type error, I can't do that to var. And then I will make a string copy of that variable and then try to print it. So now my script is a little bit more robust. If it encounters different kinds of errors, it can deal with them in different ways. As it stands right now, I can't do that to var because I made it an integer, but if I string it, you get 5. And if I go back in and I cause that name error again, we get the name error error message. So again, makes our script a little bit more robust. And, before I continue, yes, I should point out, this is very much like the way an if statement can have multiple else. You could just list as many of these as you need for the different exceptions that might occur. And if you catch one of these exceptions, again, trying to highlight the text to not move that block, if this exception occurs, you run this block of code, or Python will run this block of code for you, and then it will jump down to the end of your entire try statement and continue with whatever else is in your script. So if we ran into the first exception, we don't also have the second or third or fourth or 15th or however many exceptions there are. So there are quite a few different exceptions you might encounter, and as you start importing modules into your scripts, you might also be importing different exception types. Many modules include exceptions unique to themselves. Some common examples? Well, we've already seen our name error. If you're trying to use a variable that you didn't create yet, you will run into a name error. Admittedly, this probably isn't an error you really need to be handling with try and except. You should be writing your code so you don't run into that problem. A type error, which again we've already seen. If you're trying to use a variable of the wrong type, so when I tried to combine a string and a var, it didn't work. I got this type error. Again, this might be the kind of thing that we could write our script to actually handle and deal with properly instead of catching an exception when it arises. A zero division error. This is one you might not be able to write your script to avoid in advance. If you get a value from a user, or you're looking at the size of a file and trying to divide by that value, and that value happens to be 0, well, you just have to be able to deal with that. You can't divide by 0, so your script should be able to say, whoa, I'm trying to divide by 0 and I'm not allowed to do that, so I'm not going to. Here's an error message, and either the script continues under control or just gives that error message and exits. An index error. If you're working with a list or a collection type variable and you're accessing elements by their index, and you give either a negative value or a value past the end of the size of your collection, you'll get an index error. You're trying to access element 10 of an 8-element list. That's not going to work. And sometimes you might be able to predict that in advance. You could probably use some of the built-in function or built-in methods to say, if my index is beyond the length of my list, I don't want to do this. But you could also just catch that problem. This is by no means an exhaustive list, but these are some nice, simple, common ones you might run into frequently. And of course, when we start working with files, there are some exceptions to do with there. And I've got a nice pair of links that I'll include in the slide, and I'll throw in the description of the video to the official Python documentation for exceptions. Anytime you're using a module, read the documentation for that module, because there might be an exception in there too. We can also include an else in a try statement to have a block of code that we will run only if nothing went wrong. So I tried to open a file, maybe I have some exceptions to deal with things that might go wrong, and only if I actually successfully opened the file do I want to actually continue and try to work with what's inside the file. As we've seen, you can run a try statement without else, but sometimes it will be useful that you try, you have your exceptions if here's what goes wrong, else, if nothing went wrong, here's the rest of my code. And I'm fairly certain that's what I have in try 4. It is indeed. So I've got basically the same thing that I had in try 3, where I'm trying to print out some output. If I run into one of several different types of exceptions, I deal with those exceptions. You'll notice, though, in this case, I made var a string. So I'm not going to run into a name error. I'm not actually going to run into a type error. If nothing went wrong, yeah, it will try to print this line, it will succeed because there's no exceptions there. And if nothing went wrong, do this. Some output, the value of the variable var is 5, the string value 5, not the numeric value 5, and nothing went wrong. You can also have a block of code to run regardless if something went wrong or not. And PowerPoint messed up my indentation. Give me a second. This should look more like this. So try our potentially troublesome block of code, except multiple exceptions, one exception, any exception, whatever exceptions you want to deal with. The code to run if something went wrong. Finally, if we ran into errors or not, I don't care, run this block of code at the end. And that's in my try 5. So much like we saw in try 4 a second ago, creating a variable, trying to print it, in this case we will actually get our type error because that's an integer. So we'll see I can't do that. Oh, I actually made this quite complicated. So yeah, try, run that line. If we run into a name error, do this. If we run into a type error, do these 3 lines. If we run into any other error, run this block of code. And realistically, it would be something more complicated than just printing out a line of output. But again, I'm just trying to show you the structure of try, except, else, and finally here. Else, so if nothing went wrong, we can print out nothing went wrong. And finally, whether anything went wrong or not, regardless of what might have gone wrong, run this block of code. So we can predict this. Var is an integer, so it will try to do this and fail. That's not a name error because that variable exists. It is a type error, so it will run this block of code. It won't run this exception because we've already handled the exception. It won't run the else because something did indeed go wrong. It will run finally because that happens whether anything went wrong or not. So yeah, we try to print out the line with var, it fails, we get the type error exception line. I can't do that to var, but if you string it, you get 5. And in our finally statement, something could have gone wrong. I don't care, I'm going to run this block anyway. Maybe there is something that this code just absolutely needs to do, whether there were exceptions or not. So what we've looked at in this lesson is how to use Python's try except statements to handle errors that can occur while your scripts are running. As I've mentioned several times, the exceptions that I actually caused here are things that you would just write your script better to avoid, but I didn't want to try to demonstrate this with complicated code that might be more difficult to understand. I deliberately kept this really, really simple so we can focus on this is the structure of an except statement. This is how you deal with these errors. If you can understand try and accept with multiple names here, you can apply that to your more complicated code when you get there. And the whole purpose of this try and accept statement is it allows us to make our scripts significantly more robust. We can deal with unpredictable things on our system. We can deal with users feeding us garbage data, as they are going to do. We can at least make sure that our scripts don't do something further unpredictable, that they can exit under control. We don't leave the system more broken than it was. And I've got a couple of links here that I will include in the description of the video there's a little tutorial for how Python handles errors and exceptions, and just a list of the basic built-in exceptions that you will find in the core of Python itself. Thank you, and I'll see you in the next video.